Well, thank you very much for the opportunity to speak today. And in this presentation, what I'd like to do is to give a perspective from Geoscience Australia on how our agency has developed capability to meet the information needs of government and other stakeholders when it comes to disaster risk reduction. By way of background to Geoscience Australia, we're a government science agency. We sit within the industry, innovation and science portfolio. And our purpose is to be a source of trusted information when it comes to Australia's geography and geology. And that's for government, for industry, and for community decision making. And the purpose is that we can support evidence-based decision making when it comes to a strong economy, when it comes to a resilient society, when it comes to a sustainable environment. And under that resilient society, it includes the resilience of our communities, the critical infrastructure they depend upon in the context of natural hazards, and the opportunities to address risk where it exists. And in doing this, it aligns with one of the 7 key impact areas that we have at Geoscience Australia, and that is supporting Australia's community safety. So for over 20 years, we've taken a multi-hazard approach, broader than geological hazard, to develop information for a range of decision makers, building upon the capability that we already have. And one capability that we've had for some time is the monitoring of earthquakes. At Geoscience Australia, we have the National Earthquake Alert Centre. It's a 24/7 facility. We monitor earthquakes in our region, provide rapidly information on these events, and we are partners with our Australian Bureau of Meteorology with the Joint Australian Tsunami Warning Centre. When it comes to the information we provide, it includes shake maps. We also curate and produce the Australian Earthquake Catalogue. In turn, we use this to improve our understanding of earthquake hazard across Australia. We've added to this capability more recently in enabling members of the public to submit felt reports. And an example of the use of this opportunity to submit felt reports was following the Victorian earthquake of Woods Point, September 2021, where we received some 41,000 felt reports from the public, and were in turn able to communicate that information back to external users. When we assess impact, risk and mitigation, we use the same approach used in the financial sector, where we bring together hazard, exposure and vulnerability. Increasingly, we are nuancing our view of risk with resilience, and also there's a greater and greater demand for information on what to do, how to mitigate the risk where it exists. Our hazard scope is broader than geological hazards, so we also include weather-related severe events too. Now, an example of how we bring these elements together is the tool HAZIMP. It's a modelling application where, for example, for wind, we can bring together the wind hazard, the exposed buildings in our communities, their vulnerability, and at a range of geographies, we can assess impact and risk. An example of where we've used this tool, HAZIMP, is with the recently completed severe wind hazard assessment for southeast Queensland. This was a major project over 2 years with some 19 stakeholders, 15 partners, including the insurance industry. And the reason for the interest in southeast Queensland is the concentration of a community exposed to severe wind there. The study region you can see in the middle of the slide, the 6 coastal councils, and in them some 3 million people live. It's 56% of Queensland's population in one location, 900,000 homes, as well as strata title. You can see examples of the house types on the right. And for our stakeholders, they wanted to better understand the risk severe wind pose, cyclones, thunderstorms and synoptic events, and how that might change with climate change, the strong growth that's occurring in this region. What are the opportunities to mitigate it? How to communicate this information to those that can invest in mitigation. Now, to understand the vulnerability of these homes, we made use of a tool, a software application developed at Geoscience Australia in collaboration with James Cook University. It's an engineering approach to assess the vulnerability of houses, and how that vulnerability might change with mitigation interventions. So to show the information that is produced, if we take one of those house types, the top left, it's called the Queenslander. We can look at the vulnerability of the house as it is in the top left graph. We can then look at how that vulnerability reduces, or the expected loss with increasing wind speed, with a range of interventions. So from that, we can actually look at the risk of the property as it is. We can look at how that risk changes at property level. We can look at it on a regional scale. We can explore how mitigation could be rolled out over a period of time across the region. We also work with critical infrastructure asset managers. And one project where we did this, completed just a few years ago, was the Earthquake Impact and Risk Assessment for Perth and Supporting Infrastructure, ERAPSI. It was a GA co-funded project with the water sector, power transmission and transport sectors as partners, as well as the State Department of Emergency Services. Looking at their infrastructure facilities, we took a systemic view, and to do that we made use of a software application developed at Geoscience Australia called the System for Infrastructure Resilience Analysis, SIRA. And what that enables us to do is to look at a facility at component level, look at its respective vulnerability of the components, how they are damaged, what that means for system behaviour, and what that means for delivery of service. So as an example, if we take a transmission substation, we have a schematic of how the substation works. We can, through a Monte Carlo process, simulate the damage to the components in this facility with increasing hazard. We can look at the damage state of the components and put it into a network model where we can look at what it means for delivery of service right after the event. And then working with industry, we can look at the recovery prognosis of these assets and what that means for the recovery of delivery of service by that facility. Now, what that enables is for infrastructure asset managers to identify components that may warrant a priority when it comes to mitigation. And what we're also able to do through this application is to generate fragility curves for different types of critical infrastructure assets that we can use more broadly. Looking ahead, we want to take our alerts through to impact forecasting. And we have the prototype Natural Hazard Impact and Risk Service. It's an enablement of the workflows of HAZIMP, where we could take, for example, a shake map from NEAC and simulate what that means in terms of damage to buildings and infrastructure, and communicating it to emergency management and asset owners. We want to make our data and information more discoverable and enable external users to interact with this information. So we'll be launching the Geospatial Delivery Platform to enable users to do this. And as an example, we recently did a flood risk study for the New South Wales town of Murwillumbah. The outcomes of that study have been enabled in our Geospatial Delivery Platform. So it enables an external user to explore it as a case study. We can look at the extent of flooding in this community with different average recurrence intervals. We can look at what properties are inundated. We can look at the extent of damage right out to the maximum probable flood. And then finally, we want to extend our application of SIRA to geographically dispersed systems. And that is underway, looking at the critical infrastructure corridor that runs from Perth east out to the goldfields. And we're looking at the interaction between interdependent systems, geographically dispersed, where we're looking at true infrastructure risk due to earthquake in this project. So in summary, Geoscience Australia as a government science agency is built upon its capability to meet the needs of disaster risk reduction. The focus is multi-hazard. Increasingly, the information needs deal with mitigation. We've developed capability in part through collaboration. We work with critical infrastructure asset managers in a trusted way, dealing with their sensitive information. And while not everything can be shared from that work, where possible, we share what work is done. And when it comes to the modelling capability that we've highlighted in this presentation, we share this open source. Thank you very much.